Namaste. When we look at the world around us, it's just so full of these amazing, complex things, right? Let's try and break down just one small part of it today and really understand it in a simple way.
Have you ever thought about it? जैसे रात को खिलने वाले फूल. Why are they almost always white? या फिर एक कैक्टस को इतने सारे कांटे क्यों चाहिए? Well, all these fascinating questions, इनका जवाब एक ही सब्जेक्ट में मिलता है. And that subject is ecology. So, let's start right there. सबसे पहले let's get a handle on what exactly ecology is. आखिर ये है क्या और किस तरह के सवालों से डील करती है?
Basically, you can think of ecology as the subject that answers both the how and the why questions about nature. For instance, how does a bird sing? Well, इसका जवाब physiological है, उसके voice box के mechanism है. But the more interesting question is, why does it sing? Or इसका जवाब behavioral है, to communicate with a mate during breeding season. Ecology, you see, looks at both.
Okay, so within ecology, we generally look at four main levels of organization. We've got organisms, then populations, communities, and finally, biomes. हर level की अपनी अलग study होती है. Like in आज, we're going to zero in on just one of them, populations.
All right, let's dive right in. So what is it that makes a population a population? What makes it so different from just a single individual organism?
Well, think about it like this. एक pond में जितने भी lotus plants हैं, वो एक population है. या एक जंगल के सारे teakwood trees. That's a population. Even all the rats in a city. Basically, it's a group of the same species in the same area, sharing resources and, well, competing for them too. And here's the crucial point. A population has certain characteristics or attributes that an individual just can't have. For example, an individual has a birth and a death. लेकिन एक population का क्या होता है? It has a birth rate and a death rate. See the difference? Let's take birth rate for instance. The technical term for it is natality. And this isn't just about the total number of births. It's a per capita measure. Per capita मतलब per individual. हम calculate करते हैं कि average हर एक member के हिसाब से कितने नए births हुए. चलो एक example से समझते हैं. So look at this. मान लो एक pond में 20 lotus plants हैं. Over the year, 8 new lotus plants come up. तो हमारा birth rate क्या हुआ? It's not 8. It's 8 divided by the original 20. That gives us 0.4 offspring per lotus per year. It's the per individual rate that's important here, right? And exactly the same logic applies to the death rate, which we call mortality. ये भी एक per capita measure ही है. Okay, let's take another example. Imagine a lab with 40 fruit flies. एक हफ्ते में 4 of them die. तो death rate क्या होगा? It's 4 divided by 40, which is 0.1 individuals per fruit fly per week. And by looking at this rate, we can get a really good idea of the overall health of that population.
Another key attribute of a population is the sex ratio. देखो, an individual is either male or female, simple. But a population has a sex ratio, यानी what percentage of the population is male and what percentage is female.
So there you have it. Birth rates, death rates, sex ratios, these are some of the special attributes of a population. But the big question is, how do we actually measure the size or the strength of a population? Well, for that, we use a concept called population density. Population density, which we usually denote with a capital N, is basically the number of individuals per unit area. Sounds simple, right? But here's the thing. Just counting the numbers doesn't always give you the full picture.
And this is a perfect example of why. Just imagine an area, उसमें 200 छोटे-छोटे Parthenium plants हैं. और उसी area में there's one single massive banyan tree. Now purely by numbers, the density of Parthenium is way higher, right? 200 versus 1. लेकिन उस ecosystem पर किसका influence, किसका role ज़्यादा बड़ा है? Of course it's that one banyan tree. So you see, sometimes it's not about the number, but about the biomass or the overall impact.
All right, so we know how to measure population density. The next logical question is, why does it change? What are the factors that cause a population to grow or shrink over time?
Well, it really boils down to 4 basic processes. दो चीजें जो population density को बढ़ाती हैं. Natality, which is the number of births, and immigration, which is when individuals from outside come in. और दो चीजें हैं जो population को कम करती हैं. Mortality, the number of deaths, and immigration, which is when individuals leave the area.
And we can actually put these 4 factors into a really simple equation to predict what a population will look like in the future. The population at a future time, NT plus 1, is simply the population right now, NT, plus everything that adds to it, that's births and immigration, minus everything that takes away from it. That's deaths and emigration. It's that straightforward.
Okay, now we're getting to the really interesting part. How do populations actually grow? Are there predictable patterns? Is it just random, or can we model it? Let's find out.
So, the first model we have is called exponential growth. Now, this is what happens in a perfect world, an ideal situation where resources, food, space, everything are completely unlimited. When that happens, a population can grow incredibly fast, in a geometric progression. और जब आप इसको graph पर plot करते हो, you get a classic J-shaped curve.
There's a famous old story that perfectly illustrates this. एक king ने promised किया कि वो chessboard के पहले square पर एक दाना गेहूं रखेगा, दूसरे पर 2, तीसरे पर 4, and so on, doubling it each time. It sounds manageable at first, right? But before he was even halfway across the board, the king ran out of all the wheat in his entire kingdom. That's the incredible, explosive power of exponential growth.
But we all know that's not how the real world works. In nature, resources are always limited. No population can just keep growing exponentially forever. And that's why we have a much more realistic model called logistic growth.
This is where a super important concept comes in, called carrying capacity, which we represent with the letter K. Carrying capacity is basically the maximum population size that an environment can support over a long period of time. So what happens is, as a population gets closer and closer to this limit, its growth starts to slow down. And this creates a very different kind of curve on a graph, an S-shaped or sigmoid curve.
फ्रेंड्स, इस वीडियो को पूरा देखने के लिए आज ही फ्लेक्सी टीचर ऐप सब्सक्राइब करें, जहां आपको मिलेंगे एनिमेटेड वीडियोस, डिजिटल बुक्स, टेक्स्ट बुक सॉल्यूशंस, नोट्स, डीपीपी और क्विज। और हाँ, फ्लेक्सी टीचर ऐप मोबाइल, टीवी और कंप्यूटर पर अवेलेबल है। और अगर आपके पास इंटरनेट नहीं है तो तुरंत ऑफलाइन सेट टॉप बॉक्स के लिए संपर्क करें। फ्लेक्सी टीचर, द वन यू नीडेड।